Yeah, so derivative of this upside or numerator, this is e to the power x. So derivative of e to the power x, it is e to the power x, and derivative of cos x, it is minus sin x. So ultimately the answer is e to the power x plus sin x. And now we can plug in the value, right? Because e to the power 0 is 1 and sin 0 is 0. That means on plus 0, that means 1. Okay, so Alamin, can you understand?
Yeah.
Michelle, can you understand?
Yes.
Okay, so number 4, for what value of a is f of x square plus 1 where x is less than 3 and 2ax where x is greater than or equal to 3 continuous at every x. So that means this value, this function here, this is not complete, right? We have to find some value of a to make it continuous. We have to find some value of a, right? So firstly, let's so where is that? Yeah, number 4. So firstly, let's see the left hand limit and the right hand limit. Okay, because to make the function continuous, we have to make the left hand limit equals to right hand limit is equal to the function value, right? This is the condition. So the left hand limit, it will be this one, right? So here you need to find what is the value of x. Value of x is 3, right? Value of x is 3. So this is our left hand limit because here x is less than 3, and this is our right hand limit because here x is greater than or equal to 3. So now you have to calculate the left hand limit and right hand limit. So for left hand limit x tends to 3 minus f of x, it is x square minus 1. Okay, because for left hand limit our function is x square minus 1. So if I just plug in the value here, so I will get 3 square, that means 9 minus 3 square means 9 minus 1, that is 8. So this is the value of left hand limit. And right hand limit, for right hand limit the function is this function, right? Because here x is greater than 3. So we come here and we write down this function, and now we have to substitute the value here. So 2a into x, that means 3 multiplied to 6a. So from the condition we know that left hand limit, right hand limit, and function value, they will be similar. That's why I write down this way, f of 3 also. So let's calculate the function value. So we already found that x is equal to 3, right? So for function value we have to take this function, because for this function x is equal to 3. So if I substitute 3 here, so I will get 6a. I will get 6a. So if we want the function to be continuous, then our condition is their left hand limit, right hand limit, and the function value is same. So you can just take these two things. Okay, 8 is equal to 6a. So here a will be 4 by 3. So this is the answer. Guys, can you understand?
Yes.
So we can move forward to number 5. if x is equal to 2x plus 3, 2t plus 3 and y is equal to t square minus 1, find the value of dy by dx at t is equal to 6. So you see here, this is some kind of parametric equation, right? Because we have two variables here. We have two different variable x and y, and they depend on another variable t. Okay, so this is a parametric equation. So in this case we have to divide we have to find the differentiate in terms of t. Let me show you here. So we have to find the derivative of dy in terms of dt in both upside and downside. Okay, so if I differentiate this function, the upside function in terms of t, so we will get 2, only 2, right? Sorry, 2t, we only get 2t. It was t square. Okay, yeah, so dy by dx. So here this is t square minus 1, so derivative of t square minus 1, it will be 2t, and derivative of 2t plus 3, it will be only 2. So I can cancel 2, we get finally we get t. So dy by dx, it is t. Now we have to calculate where t is equal to 6. So we just need to plug in the value 6 here. So if t is equal to 6, so we have to plug in the value here. Okay, so also dy by dx will be 6. So this is the final answer. Guys, can you see this step? This is a parametric equation. That's why I divide dt on both upside and downside. Okay, then I calculate this part, so I get 2t, and then I calculate this part, so I get only 2. So Michelle, can you understand? No question. Okay, thank you. Alamin, how about you?
Yeah. Pretty much.
So Michelle is going a very good student. Okay, so
Yeah.
number 6. Number 6, we have to evaluate integration of 1 by x into 1 plus x cube dx. So number 6. So you can see that this function is very complex, right? So again we have to divide this, and okay, so we can use u substitution rule here, because this x cube, if I let u is equal to x cube and I differentiate on the both sides, and you see here I have some kind of x square and dx, right? So if I substitute x cube is equal to u, then I have to also I also have to convert this x square and dx into some kind of du, right? Something multiplied to du. So that's why here I can see we have x square dx. So I only keep x square dx on left side and everything else on the right side. Okay, so I get x square dx is equal to 1 by 3 du. That's why I write down here 1 by 3 du, and instead of x cube I write down here u, because in this line we are using u substitution rule. Okay, and that's why our variable also needs to be same. Like if I write down u here, then our variable here also have to be u. Okay guys, am I clear?
Yeah.
Okay. Now take the constant out. So we get 1 by 3 integration of 1 by u into 1 plus u. So this part is, I need to write down du here. So this part is also complex, right? Because we don't know how to calculate 1 by, we know how to calculate 1 by u. Because there is a formula for 1 by u, but we don't know how to calculate 1 by u into 1 plus u. That's why we have to divide this part. So for this reason, I just multiply u on the upside, and also I minus u on the upside. Okay. So I can cancel u, and ultimately I get the previous part. Okay. So what is the benefit? Oh, sorry. So the benefit here is, if I divide from here, so if I divide from here, I will get 1 plus u by u into 1 plus u, then minus u by u into 1 plus u. Okay, am I right? If I divide from this minus,
Yes.
so I will get something like this. So I can cancel 1 plus u and 1 plus u, right? And also I can cancel u and u. So ultimately I will get 1 by u minus 1 by 1 plus u. Am I clear, guys?
Yes.
So we can write down this here, and then I distribute integration sign. I distribute integration sign here and here. So integration of 1 by u, it will be ln u, right? And then we substitute back u here. So we already let u is equal to x cube. So we substitute back u here, and integration. So we can just also again so here this 1 by 3, they have multiplied this 1 by 3 with the bracket. Okay, they have taken this 1 by 3 with this one, and also with this one. So this is 1 by 3. Okay, this 1 by 3 comes from here. Okay, don't worry about this 1 by 3. And now we have integration of 1 by 1 plus u, right? Integration of 1 by 1 plus u. So again, I can use some trick here. For example, du, this is equal to du plus c, right? Guys, am I right? Like derivative of a constant, it will be 0. So I can write down du is equal to du plus c. So here I have integration of 1 by 1 plus u. So I can also write down here u, instead of du, we can write down du plus 1. Okay, because they are same.
Yeah.
And now, so I get some formula here. Integration of 1 by u, right? If I just let this part is equal u, and you see here that this part and this part, they are similar, right? As they are similar, that's why we directly can apply apply our rule. So you can follow another step, like you can use again you can use u substitution rule here. Okay, but we are skipping some steps here, because if we want to add plus 1 here, so the steps will become more easier. Okay, we can directly write down ln u or ln 1 plus u. Okay, so we can directly write down ln 1 plus u. and then you substitute u here. So we get ln on plus x cube, and then plus c at the last. Okay. So now for this minus, you can divide.
Hello?
Yeah, sorry, my internet connection was lost.
It's okay.
So for minus, you can just use divide sign, right? So x cube divided by on plus x cube. So this is the final answer. Now let's go to number 7. We have to evaluate the integration of on to ex ln x dx. So again, we know how to calculate ln x dx. Sorry, we don't know how to calculate ln x dx. Sorry, we know how to calculate on by x dx. Integration of on by x dx. Okay. So we don't know how to calculate ln x dx, and we also don't know how to calculate this whole part. So that's why we need u substitution rule. Okay. So we let x is equal u. Sorry. Here is some I mean some order. Okay, guys, still remember I love page? Maybe I taught Lucy, not Michelle. We were having some group study with Lucy and others. So there is some kind of trick. Okay, I love pet. So I means inverse trig function. Love means log function. T means power function. E means expo function, and T means trig function. Okay, so this is the order for selecting U. So here we see we have a log function and we have a power function. So firstly we have to take log function as U, right? Michael, Alamin, can you understand?
Yeah.
Michael? Sure.
Could you repeat it, please? Like,
Yeah,
could
so
you please repeat it?
we are using,
Yeah, the formula. I love pets. I didn't get it.
yeah, so so there is, here we are using U substitution rule. So there is some formula to select U. So we have here x, that is a power function, and we have here ln, that is a log function, right? So the order is from left to right. The first priority is I, that means inverse function, inverse trig function, that means arc. Okay, arc sin x, arc cos x,
Okay.
and log, that means log function. It can be log, it can be ln. Okay, and p means power function. Power function means x square or x cube. Okay, and e means expo function. Expo function means e to the power x, and t means trig function, that means sine cos, sine a, cos a. Okay, guys, am I clear?
Yeah, now I get it. Yeah, now I get it. I get the sense now.
Yeah. So we get here log function and expo function. So we know that our u will be log function. So ln x is equal to u. Okay. So u equal to ln x, and now we have to find the now we have to find the, we have to differentiate on the both side. Okay, guys, see here, u equal to ln x. Now differentiate on the both side. That means du is equal to d ln x. So d ln x will be on by x, right? On by x. 1 by x derivative d ln x ln x derivative is 1 by x, okay, du. dv. Okay, so we have to find dv, okay, guys. We need to find dv. Because do you still remember the substitution rule for integration? Integration of u dv is equal to uv minus integration of v du, okay? This is the integration, the u substitution rule of integral calculus. So guys, we need to find some, we already know that u is equal to ln x. Now we have to find dv, okay? So dv means integration of this function, okay? So
Yes,
we let
sir.
ln x is equal to u. So only x is left. So now we have to calculate the integral of x. So integral of x will be x squared by 2. Okay, guys? I think you can calculate this. So this is our dv. Am I clear?
Yes.
So firstly, we let ln x is equal to u. Then we have only x left. So we have to find the integral of x. The integral of x is x squared by 2. So this is our dv, okay? dx squared by 2. So now we can use substitution rule, okay? Because substitution rule is here. Integration of u dv. So we got integration of u dv, right? Integration of u dv. So the formula is u multiply v minus integration of v du. So u multiply v minus integration of v du, okay? Now if you calculate this part, so so this is a long line, okay? Like firstly you have to substitute the upper limit here. So ln e, it will become ln e and e square by 2, ln e into e square by 2, and then you have to substitute the lower limit here. So it will become ln on into on square, that means 1 by 2, okay? So this part is for this part, okay? Guys, do you understand?
Yes.
Okay. Now minus integration of on to e x square d x square by 2 d ln x. Now this part, okay, this part. Let's calculate this part. So you see here d ln x. So from the formula, derivative of ln x is 1 by x dx, right? 1 by x. Guys, do you still remember the formula?
Yes, we do.
So
Yeah.
ln x derivative is 1 by x. So so we can take this constant out. So we take this 1 by 2 constant out here, okay? Oh, sorry. Not right now, not right now. So constant is still here, okay? So we can cancel this x. So we get 1 by 2 x square.
Get x over 2.
No, not x over 2. Here is something missing, I think. Half x square. Derivative of ln x on x. x square by 2x. It should be x square by 2x, but you see here x square by 2 into 1 by x. So it should be x square by 2x, right? Or only x by 2.
I think we get x over 2. I think there's something wrong about your notes.
This part? Okay, let me check our Laoshi's note. Where is that number? Aha. So this is number 7, right? Oh yeah, Laoshi cancel this here. Laoshi cancel the onyx from here. Guys, can you see? I have to zoom in. So guys, can you see Laoshi cancel onyx from here? But how do she get x square?
Okay. How come if Oma, how come if we cancel one x here and get another half x squared again? It doesn't make sense.
Yeah, sorry, could you please tell again?
Okay, I'm saying, how can she firstly cancelled another x, then she give us the answer half x squared again. How come if she cancelled another x, it's supposed to be x over 2?
Yeah. Let me see back in my note. Where is that? X squared by 2 into 1 by x dx. E squared by 2 and ln constant is 0. Okay, let's go. Let's see the next line. Okay, so what do we have? So maybe we can find some solution. So ln e into e squared by 2. So it makes e squared by 2. But how about ln e? Ln e is equal 1. Maybe yeah, ln e is equal 1. Okay. Ln e is equal 1. So 1 into e squared by 2. And minus. Here is minus. This is ln constant, right? Ln 1 by 2. So ln constant value is 0. Ln any constant value is equal 0. Okay. So this part is 0. This part is 0. So that's why we don't need to write that part. And minus this minus here or here. So yeah, this minus is here. This minus is here. Okay. And for this part, we need to oh, I'm sorry. Integration of 1 to e x ln x dx. Let me see the answer. Okay. E square by 4. E square plus 1 by 4. Okay, fine.
You integrate
So
it,
yes,
yeah, x over 2.
the value of, yeah, so we can cancel this x here. So we get x by 2, and then we have the integration sign, right? So we have to calculate the integration of
Yes.
x by 2. So integration of x by 2, that is x square by 4. Okay, x square by 4.
Yes,
So
yes.
that's why we write here x square by 4. Where is x square by 4? Oh yes, x square by 4. That means on by 2 into on by 2. That means on by 4. So x square by 4 will be fine. So yeah, now just substitute the limit. Okay. Substitute upper limit and minus lower limit. Okay, guys, do you remember integration of a to b f of x? We can write down this way, like f of b minus f of a, right? Guys, I'm really sorry. My internet is horrible. Horrible. Yeah. So, do you remember some formula like this?
Well, can you hear me?
Yeah, I can hear you. Okay, so the last two line. So from this line, we just cancel on x and we get x here. So then we have to calculate the integration value of x by 2. So integration of x by 2, that is x square by 4. And then we have to substitute back the limit. So we have to firstly we have to substitute the upper limit, and then minus we have to substitute the lower limit. So if we substitute the upper limit, so it will be 1 by 4 e square, 1 by 4 e square. Okay, we substitute e here. Okay, and then if we substitute minus, then minus, but why it is plus, it should be minus. X square ln x.